Okay, so this last video 4, is going to be talking about the marginal effects in multivariate models. And this is a very traditionally interpreted, in fact, the traditional interpretation of multivariate models. So multivariate models are using multiple variables to define a plane. I'm showing you this plane in 3 dimensions. It is entirely possible to have a 10-dimensional, a 100-dimensional, a very, very large dimensional plane that's defined with 10 or 100 or 1,000 variables. So if you have 10 variables in your regression, it's a 10-dimensional object. If you have 10,000 variables in your regression, it's a 10,000-dimensional object. These get very complicated to interpret the more dimensions that you add. But we're going to make a step here and we're just going to interpret 3 dimensions. And I think it actually has some really important parallels to moving beyond 3 dimensions and interpreting the models. So for the multivariate model, it is defined in terms of a best fit plane that is defined by 2 coefficients for a 3-dimensional object, which is using 2 dimensions to predict a 3rd dimension. So Trump shift is predicted by a coefficient on median income, negative 0.000013. This has an extra 0 compared to the prior regression that involved income, plus 0.344 times high school degrees or less, plus a constant 14.31. This time that constant is indicating where does the regression plane hit the xy is equal to 0 line. So I'm going to talk you through visually interpreting the meaning of the coefficients negative 0.000013 and 0.344. Now, as before, I'm color coding things. The green coefficient corresponds with this green line. The yellow coefficient corresponds with the yellow line in the 3-dimensional graphic. The yellow line, each of these 2 lines, is the marginal effect of that variable in the multivariate model. And so here, instead of looking at the red line, which was the univariate regression using median income plotted in 3 space, or the orange line, which was the univariate regression using education plotted in 3 space, even though it does exclude income. So here we've got 2 marginal effects. Now these 2 lines define the entire plane, and we're going to start by focusing on this yellow line. So that yellow line is representing the increase in Trump support as you increase the percent of the county with high school degrees or less. What you can see is that the relationship is positive. This is very similar to what the relationship was for education in the univariate model. But on the left-hand side, instead of plotting scatter points, because as we'll see in a minute, they would be really hard to interpret in this graphic, I'm going to plot a predicted line for the percent of the county that has a high school degree or less against the predicted value. So that yellow line is a predicted value. It's saying, what would I expect based on the regression line for the value of the shift towards Trump to be. We usually plot these as predicted values once we've got multi-dimensions going on, because it's hard to understand what's going on if you're plotting something in 3 space and plotting the points there too. On the right-hand side, we've got the regression plane. And the regression plane, especially once you see it in 3 dimensions, it makes a lot more sense what's going on with these plots, these points. So these points are going through best fitting the cross-section of data that's holding income constant. So this line wouldn't make much sense if it was trying to fit this entire bulk of data, but since this line is only fitting this small cross-section of data that's holding income constant, it is in fact the best fit line for that small cross-section of data. What this means is that you would expect to see a 0.344% increase in the county shift supporting to Trump for every 1% increase in enter education, but only when income doesn't change. So for this particular 3-dimensional graph, I have shown the effect of education plotted at the average of income. This regression line would be identical if I plotted it at, instead of the average of income, which is around $50,000 per year, if I had plotted it at $100,000, for this linear model, that regression line would be the same if it had gone across this section of the graph instead of the section at $50,000. So the effect is very similar for income. The coefficient on income is 0.000013, which means that for every $1,000 increase in county median income, there's an associated 0.013% decrease in county shifted support to Trump. Again, this is when education doesn't change. So now I'm going to go ahead and flip this graph so that I look at the marginal effect of changing median income when education is held constant. And it's an even more interesting assumption to think that education doesn't change when income changes. If we look at this from a different view and look at how much can income really change for a given level of education, and it's about half of the range of the data is my approximation based on looking at this. But it's certainly not true that you can go from a median income of $20,000 to a median income of $70,000 and stay the same level of high school degrees. If you want to increase your income, well, if counties want to have higher median incomes, really, because this is county level data, you have to increase your education level. Marginal effects are extremely useful for defining the entire regression plane. They are also a little bit limited and in ways that are hard to interpret unless you see them in 3 dimensions. And so this explanation that I've just shown you is something that is not commonly interpreted because we don't usually see these things in 3 dimensions or more. Again, does it make sense to only consider what happens when education doesn't change? There are plenty of counties. If we look at this graphic, we've got high school degrees on the y-axis and median income on the x-axis. So there are plenty of counties that have $35,000 of median income and 60% of the population lacking college degree, any kind of college experience. But are there any counties that have a 60% of the population with high school degrees and a $75,000 median income? Really not. It's impossible. So is it generally possible to change income by more than $40,000 without also allowing education to change? I will note that this regression plane is more powerful than we usually use it for as a concluding note. So I've shown you 4 different regression lines, and these 4 different regression lines are all typically interpreted in one way or another in multivariate regression analysis. But what I find absolutely fascinating is that we never look in any other direction but those 4. And when we look at the direction of the univariate regressions, we usually misinterpret it. So one of the challenges I have for you if you go on in this field is try and figure out what other direction could you look in the regression plane that might be a useful direction.